Chapter's live stream from London Transport Museum. My name's Chloe, I'll be your host, and joining us we've got expert engineer Pallav. Hi Pallav.
Hi Chloe.
Hello. At the London Transport Museum, we tell the story of how people travelled around the city in the past, how we travel in the present, and how we might travel in the future. What types of objects do you think we might have in our collection to help us to tell that story? You've got 30 seconds to come up with at least 3 different things with the person next to you. Go for it. Your challenge was to come up with at least 3 different things that you thought we'd have in our collection at the London Transport Museum. How did you do? Did you get just the big things or some of the little things as well? We've got over 500,000 objects in our collection. From big things like buses, taxis and trams, and small things like these train tickets, uniforms like the one this bus conductor's wearing, photographs and posters too, over 15,000 of them. Looking back through the collection, we can see that the way we travel around our city has changed over time. That's because engineers like Pallav have come up with ways to improve the safety, efficiency and sustainability of the vehicles that we use, as well as the way we use them on our transport network. That's because engineers are problem solvers. What do you think are some of the transport problems we have in London today? I'm going to give you 1 minute to come up with some together. Welcome back. I'm sure you had lots of great ideas about some of the transport problems we have in London today. Among your answers, I wonder, did you think about the number of people in London and how this many people travelling around the city can cause traffic? Did you think about it being harder for people to squeeze into buses and trains? Did you think about air pollution caused by some of the gases released by our vehicles, which can damage our lungs? Did you think about how the buildup of other gases in the atmosphere released by our vehicles leads to a warming of our planet and climate change? Our topic for today is how we can find sustainable solutions to today's transport problems. When we use the word sustainability, we're talking about preserving the planet, its resources and environment. When we're thinking about transport and sustainability, we're focusing on how to travel in ways that have as little impact on the planet as possible. Have a look at these different vehicles. There's a double-decker bus running on biofuel, which is a mixture of diesel and leftover fats and oils from making food. There's a car, a hybrid taxi, which uses a mixture of diesel and electricity, a cycle hire bicycle, and a single-decker electric bus. They were all developed by engineers to solve the problem of us needing to get from one place to another, but some are more sustainable than others. Can you rank them from the one you think makes the least impact on the planet to the one you think makes the most? Remember to think about how each vehicle is powered, how many passengers each vehicle can transport, and the amount of material it takes to make it in the first place. I'll give you 3 minutes. Remember to share your reasons too. Hello again. How did you get on? Which of those points was the most important for you in terms of how sustainable you thought a vehicle was? Was it how it was powered, or how many people it could carry, or how it was made? All of these vehicles are on London's roads today, and they can all be changed by engineers to make them more sustainable. That's why our question today is, how can we redesign our roads to encourage us to choose to use the more sustainable vehicles that exist today? Let's talk to our expert engineer, Pallav, to find out more.
In my job, my day-to-day thing is how can we make road more accessible to the people? How can we make it more safe to the people? And how can we ensure any kind of work that happens on the road is sustainable, is happening in a proper timetable, and is happening with everything keeping in mind safety and within the cost. Now, apart from this, what I also look after is the traffic lights. You will be having few questions on traffic light, and I'm looking forward to the answers from you. Um, how do traffic light perform if there is a road congestion in particular area of London? How do we ensure that the London doesn't get clogged? Because if one street is having a severe congestion, I'm pretty sure nobody in that area would like to see whole raft of air coming, polluted air coming out, the journey time being excessively longer, and how can we ensure that traffic moves smoothly throughout the city?
Am I right in thinking that you're designing cycleways now? You're thinking about where people on bikes can travel on the roads. Is that right?
Correct. Yes, that is true. So, what happens was during pandemic when everything was at halt, what was allowed was people can move only for exercise purpose, and that is where the idea came in. Look, if things go back again to normal, and if we do not change the air quality of London, then we're not creating an impact and we're not using this time wisely. So the mayor's directive and within our engineering community, there was a lot of drive to really become more, to create a cleaner London.
Mm.
And that is where we came up with uh, creating the biggest corridor, cycling corridor within UK. We are equally competing with Europe as well, but it was definitely biggest within the UK. And this cycling corridor involved how can we change the road layout so that the traffic runs smoothly, the buses run smoothly, the pedestrians are safe, and we have ample of spaces for cyclists to really go along smoothly on those journeys. What we realized were there were some challenges. Space definitely was, changing the behavior of people definitely was, and then people always felt, hmm, cycling on London, not a safe idea. So all these were kind of challenges that we had to really deal with.
Wow. Okay, we are going to take that your recent challenge and we're going to ride with it. Let's have a look at some of London Transport Museum's collection to do with cycling. How about this road, this photograph of a road outside Vauxhall Station? How many forms of transport can you spot? Can you spot a cyclist or even more than one? I'll just give you a few seconds to look because they're quite small. Do you know the name of the big vehicles? And can you see how all the vehicles are sharing the road? I wonder if they'd agreed on that, Pallav, before. Do you think there was like laws saying that the cyclists would go in one part, or would everybody mix in together, do you think? It was quite a long time ago.
1912 was a time when things were changing and automobiles were coming onto the road. And there were no particular laws that would define that the cyclist would remain on the left or the motor vehicles would be on the right. So it was all a jim jam kind of situation where people can go anywhere, and it was definitely not that safe.
No, it doesn't look that safe actually. Thank you. Okay, well, how about this photo? Because the cyclists are a lot clearer here in 1930. What, or rather, who is controlling the traffic? Hmm, different to maybe what controls the traffic for us now, Pallav, like you were saying before, with your expertise in traffic lights. So we've actually got a police officer there, and I think they're kind of stopping and bringing forth the traffic.
Yes. So what has happened over the period of time is because there were a whole raft of road accident and more cars were coming onto the road. People were preferring and moving away from the cycles and going into the cars because they felt quite comfortable. They didn't have to push and they could go from one place to other place over a longer range of distances. They were much quicker. They were saving time.
Mm.
And that is when this transition, because of this transition, people have to be controlled in their behavior. And that is why you will see a traffic policeman at the quadrants.
Interesting, thanks very much. In 2010, I think, Transport for London launched their cycle hire scheme. Here's one of their prototypes, which is like a model bike, and a leaflet as well, helping to explain how to use the scheme, as well as a photograph to show all the bikes lined up in their docks, like you can see all around London today. The cycle hire scheme has been going for 11 years. Happy birthday, cycle hire scheme. And there are 11,500 bikes to hire. To celebrate, let's do a cycle hire quiz. Woo! Okay, in your classes, see if you can come up with an estimate of how many cycling trips Londoners have made over the past 11 years. Is it A, 980,000 trips, B, 9.8 million trips, or C, 98 million trips? You've got 30 seconds on the clock. Vote now. A, B, or C? The answer is C, 98 million trips.
That's a big number, isn't it?
Isn't it? It's huge. And Pallav, did you know that? You were nodding, going,
Yeah.
yeah, that is incredible. So successful, the scheme. Unbelievable. Okay, so 98 million trips in 11 years. Question 2. The distance covered by those 98 million cycling trips is the equivalent distance of A, 2 return trips to Mars, B, 2 return trips to Jupiter, or C, 2 return trips to Neptune? Another 30 seconds on the clock. Vote now. A, B, or C? It's A, 2 return trips to Mars, which is the closest planet, I guess, but it's still a really long way, isn't it? Apparently, it's a distance, Pallav, of 300 million kilometers.
It is. It is. And this
Unbelievable.
is what is surprising. Now, if you look in 11 years, we have been able to bring people away from cars to really cycle. And if you transfer that distance into the amount of air that would have been polluted by how many people would have gone by their bike or their cars, that is a massive impact on the environment.
Wow, of
So
course.
we definitely can't undermine how important and how critical these cycling schemes have been.
Absolutely, that's amazing. Yeah. Last question, inspired by Pallav there. The average car releases 122 grams of carbon dioxide every kilometre it drives. Carbon dioxide is the gas that builds up to warm up our planet through the greenhouse effect. If people using the cycle hire scheme would have otherwise driven those 300 million kilometres, how many balloons worth of carbon dioxide haven't been released into the atmosphere because of the cycle hire scheme? Is it A, 486,780 balloons worth of carbon dioxide? Is it B, 486,780,000 balloons worth of carbon dioxide? Or C, 486,780,000,000 balloons worth of carbon dioxide? It's your last chance. Vote now. A, B, or C? It's C, 486,780,000,000 balloons worth of carbon dioxide that haven't been released if we imagine that all those people, well, all those trips on the cycle hire scheme would have otherwise been made in cars. Wow. How many of those questions did you get right? It's the taking part that counts. So well done, everybody. Lots of people are cycling, and that's a great thing for reducing the air pollution in our city and also slowing down the warming of our planet. It's also good for helping our buses to run on time and to decrease traffic, as less cars mean more space on our roads. Want to know more? Give me a thumbs up. And freeze. We need to use your thumb to help us with some calculations. Let's say the length of your thumb is the amount of space that a car takes up. Okay? The average car in London has 1.5 people in it, just 1.5 people. So starting from your wrist and ending at your elbow, how many people could travel along a road the length of your arm at the same time if they were all in cars? Have a go now. Oh, remember to leave gaps between your thumbs so there's room for your cars to brake. So my thumb car fits along my arm road roughly 3 times. That's 1.5 people plus 1.5 people plus 1.5 people. That's only 4.5 people who are able to travel along my road at any one time. How about you, Pallav? How many of your
It was pretty much the same. It's not very different.
That's interesting. I wonder if everybody else is doing it in their classes and they've all got 3 as well.
It would be interesting to see.
Remember, you can always let us know on social media. We'll give you the details at the end. Okay. How many people could travel along your arms? We had 4.5 if they were all in cars, but how many could travel along at once if they weren't in cars, but they were cycling instead? Now, we need to know something, don't we, before we can do that calculation. How many bikes do you think can ride in the same space as one car? I'm going to give you 10 seconds to take a guess. Oh, time's up. It's 5 bikes. 5 bikes within the space of one car. Did you get it right? Or did you get a bit more or a bit less? Let's do our new calculation. So if 5 people can ride their bikes in the same space as one car, which holds only on average 1.5 people, how many people could travel along the road the length of your arm at the same time if they were on bikes instead of in cars? Remember to leave gaps for them to brake again. So I could fit in along my road 5 people on bikes, plus 5 people on bikes, plus 5 people on bikes. That's 15 people compared to 4.5. So that's so much more. So many more people can travel all at once. Did everybody else get that as well? A lot more people if they're all on bikes instead of in cars. And for Pallav, that's a big deal, isn't it? Because
It
you're
is.
trying to design roads in a way that's keeping as many people moving at once as possible.
It is definitely, because what we really need to ensure that we use just the right amount of space on the road to keep everyone moving. Now, if you say that if you take a space of one car from or one lane out of it, you can accommodate a lot more cyclists in there rather than just one lane of cars. So if you do the same calculation over the same duration of length of road, you will see if there are 3 cars on a stretch of road, there would be probably 15 bikes standing in the same stretch of road. Now imagine if we just take out one lane and convert it into a whole cycling lane, which pretty much gets occupied approximately 25% in the worst case. In the peak hours, it's 90% or even 110% used.
Wow, that's
So
amazing. That's a massive difference.
yeah, so over a period of time, over a 12-hour clock, 25% is a big enough number to really pull out all the air that could be toxic to London's environment, and then use it and offer it to someone who can cycle and stay healthy.
It's almost time to pass it over to you now because it's nearly challenge time. Yes. To set the scene, literally, check out this 2-minute video of the setting of your challenge, Parliament Square, where Big Ben is. See if you can collect the answers to all of the questions on the screen as you watch. And thank you, Pallav, for bringing this fantastic film to us.
1868. The teeming metropolis of London is overflowing with pedestrians and horse-drawn traffic. The conflicting movements cause problems for members of Parliament crossing the road on their way to work. However, an innovative solution will soon be seen for the first time. The world's first traffic signal was installed on this busy junction at Parliament Square. Proposed by the inventor John Peake Knight, it was based on his design for railway signals and constructed by engineers at Saxby and Farmer. Ingenious at the time, this traffic light improved the commute for Londoners around Westminster and tried to reduce the thousands of people that died in traffic-related incidents each year. However, it wasn't without its problems. London is still facing the same challenges today, with 31 million journeys being made every day on London's transport network. To enable TfL to manage all these journeys, we operate 6,300 sets of traffic lights that are controlled by a central computer, adjusting signal timings based on the type and use. This allows us to respond quickly to incidents, minimising any disruption to roads and focusing on sustainable modes of transport. How will continuous advances in technology and artificial intelligence shape the future of transport? Will connected vehicles communicate with their surroundings, responding to real-time information and making their own intelligent decisions? Could deliveries and public convenience jobs be made by drones or droids? Could the traffic light evolve to be a fully connected device that responds in real time to incidents and communicates with all transport modes, allowing for a safe and reliable transport system for everyone to use?
Okay, time's up. Here's the answers. How many did you get right? Pallav, we saw that traffic light blow up, right? Why might that have happened?
Earlier, the street light and the traffic signals were pretty much operated by oil or burning some kind of fossil fuel, and that is how they used to operate. And every now and then, if there was any kind of leakage or any kind of um, combustible substance around, it used to blow up. However, traffic lights have evolved over a period of time. With electricity coming in, there was uh, an effort to really make everything electrified, including the street light and the traffic light. We were using the Edison bulb, which were getting heated up every now and then, which was another problem because every now and then you were blinking traffic light. They were changing from red, yellow, green. The filament used to burn out and it used to break, which was causing a massive chaos because you have to quickly change those bulbs. Now, those were the kind of challenges, engineering challenges that we had. And they were not really very environmental friendly as well because they were consuming a lot more. They were not very energy efficient. Now we came up with another solution of LED lights, which were small miniature bits. They do not fuse that quickly and they can do the job which they're supposed to do. And they are quite well and they are very environmental friendly. They use a lot more, a lot less energy. So these are the changes that have evolved over a period of time, and these are a part of continuous engineering challenges that we face. Now, if you look in what further changes that have happened in the traffic light system is that you will see a kind of countdown clock being really accommodated. They were not there earlier.
No.
Do you think that is a deliberate effort to tell people how much time? Yes, that is, because there are people with different capabilities. There
Mm.
might be people who can't run that quickly. There are people who are quite slow, who would be going on some kind of uh, mechanism which is not really very accessible to other people. They have accessibility issues. So we need to tell them, look, there's your countdown clock. If you can cross the road, do it, otherwise stay back. So these are the things that have happened over the evolution of traffic signal and traffic lights. I'm pretty sure that would throw some light on accessibility and environmental sustainability.
Definitely. And we're going to have to be thinking about those things because it is challenge time now, and we need some help from all the problem solving engineers out there. Because the challenge is to redesign the road network of Parliament Square to make it safer for a cyclist to get from the red star to the blue star. You could try installing traffic lights, like we've heard Pav talk about there, or maybe building a separate cycle lane. How about some bridges, maybe? Not very easy to get up on your bike, or maybe some police officers stopping traffic. Or maybe, like in the video you just watched, you could think about the future. Maybe there could be robots or sensors that could stop traffic whenever the cyclists are approaching. I wonder what we might come up with together.
I'm so excited to see the answers.
Me too. So think about how your redesign, of course, might affect your buses, your pedestrians, and your cars as well, of course. So what are going to be the consequences of your design decisions? You've got 3 minutes to come up with some ideas together, and then Pallav might let us in on his suggestions too. Good luck. Welcome back. Was it easy or hard to juggle the needs of those different road users? Did you come up with a solution that was good for everybody? Did you get your cyclist safely from one start to the other? Pallav, what would you suggest as a solution to this challenge? Shall I show
You
you
see,
if I get it up on the screen?
no, that's
Would
fine.
that help?
So if you look in every now and then around that square, you have got police enforcement, you've got political people coming every now and then, you've got emergency vehicles moving around, you've got people because it's a touristic spot, you've got cars coming around, you've got Westminster Station in around, and then you've got cyclists coming in from all the corners. So now, the first thing that you really need to keep in mind is pedestrian safety. So if you can't take your cyclist up the bridge, can you make sure the pedestrian move from under the bridge? How about that? Now, the thing that you can do and you can't do are the first thing that you really need to assess. And that is the first primary question every engineer is faced. You can't take cyclists over the bridge. You can take a car over the bridge, which would be much more convenient. So if you are making any such changes on the road, questions that you need to answer is, will the bridge impact the traffic over a long run? Will it impact the environment around there? Will it impact the beautification of the Parliament Square? You definitely do not want Parliament Square to look very ugly. You really need to ensure the trees around there stay safe and national heritage remains intact. So those are the questions which I'm pretty sure some of you might have thought, some of you might not have even imagined. So these are the challenges that we face day in, day out. Now, talking about moving pedestrian under the ground, that's why you see underground tunnels really to cross the road. Now, the other thing that you can do, and which I think if you like to do a coordinated dance, you will enjoy traffic signaling, because traffic signaling is pretty much a coordinated dance. Now, what you really need to know is at what time of the day is the traffic heavy and what time of the day the traffic is light. Okay. And then what you can do is modulate the amount of interval that you offer each of the direction to really move around. However, not every signal is done in such a way, but then critical areas like Westminster definitely is taken care of on those respects. So if we know that a lot of people would be traveling from the bridge into the north side of the city, we make sure the traffic signaling is programmed accordingly. However, we know it would be the exact opposite in the evening time. So we modulate it accordingly. So these are the kind of changes that we do to overcome these kind of challenges. Now, you can't have cyclists really working around and going in the way they like. So what we do is ensure the traffic lights for the cyclists are ensured. And again, by traffic light, we coordinate them in such a fashion that that the choreography works very well and they can run smoothly.
Wow, amazing. There's so much to think about, isn't there? And I know that something you do as engineers is you kind of you evaluate and you modify your designs, don't you, constantly? So you change them in light of what you've learned. So take a look. Oh yeah, there's this pathway on the screen now that you can see. And now that you've heard what all those suggestions that Pallav's made, have a think about what you were suggesting and see if you can modify that. And now that you've actually had a practice as a whole class, why don't you think about drawing out your own road network out on a piece of paper and designing how you could design your roads to encourage the use of the most sustainable vehicles? I've had a go here. The first one you can see, I've made a key and it says bridges for pedestrians to get over the road, and there's electric buses in red, and then there's crossings where the road is just for cyclists, and that's in blue. And I've tried to give more road to cycling and to electric buses, and there's only a little bit for delivery vehicles in yellow, like a yellow route. But then I realised the forms of transport were too separate in that road layout. So I tried another, and so this time I've not put any bridges in, because I thought, Pallav, they might be quite expensive and they're quite hard to get over, aren't they? So instead, I've got traffic lights, and I've put the traffic lights, one in the middle for the electric buses in red to go around, and then some for the cyclists when they cross the path of the buses. But then the people in green, sorry, the people walking along, and I put them in green on my plan, they don't have to wait for the traffic lights. They've got their own zebra crossings. And you can also see I've drawn trees as well, extra trees to suck up any carbon dioxide, and also to make it look, maybe it could be released from a hybrid bus that goes past every now and again. And also to make it beautiful as well, like the point that Pallav made earlier about how important it is. And I've also put bike racks too, so people can lock their bikes up. Pallav, what do you think about my designs? Do you have any improvements?
That's a very exhaustive design. You have paid a lot of attention to a lot of things. However, what you touched upon is one very important point. We never, ever finish the design in just one iteration. Like you, we do several iterations of a design, and that is the crux of engineering, because there is not just one solution. Because if you have one solution, that's definitely not the right solution always, because you have definitely missed something, and you really need to relook, reassess, and reevaluate. Are there any better options? Are there much cheaper options? Are they accessible options? Are they going to make sense to everyone? So say, for example, if you have made the cycle lane twice as what they are currently, will that ensure all the cars go on time and we're not getting any clogging of cars? Because if the cars are staying there for a longer time, then we are back to the same problem. So these are the kind of things where we have to optimize the lane in such a way that the cars run smoothly and the cycling route remains smooth and doesn't get clogged up. However, we as an engineer are always assessed on the worst case scenarios. So it may happen, the best design that we have done may sometime get clogged up, and you always get the beating for that. That's the downside of being an engineer is.
Oh no, people are critical, whatever great ideas you come up with. Oh, but I guess it's cool that they actually care, isn't it? It's a job where you can really make a difference.
Yes, it is. But if you look in, when you go to Parliament Square or any of the road network, and you see those people cycling around, and even one of them tells you, you've done a fabulous job and made our cycling fun, you feel over the moon. You feel very proud of it. As I said, I was involved in development of EcoBlue engine, and one of the transit driver came back to me and said, you know what, this engine is very good. And I felt like I've done a fabulous job in this world. So having its own criticism, which is part of life, has its reward as well. When people come back to you, you feel really proud of what you have achieved. So to any budding engineer, take criticism, but do take pride in what you do, because there are people who would love your solution, love your product.
Oh, Pallav, thank you so much. And what a lovely message to end our time together on. Thank you so much, Pallav, for coming today and sharing all of your experience and knowledge of engineering. We really, really, really appreciate it. That was amazing.
It's always a pleasure to come to students and tell them about my life as an engineer.
Thank you so much. And we would love to see your designs. So once you've finished your new road network designs, please share them with us at LT Museum with the hashtag #IHeartLTM. Thanks so much for joining us today. Bye from me. Bye.
Bye-bye.
Bye from Pallav. Bye, everyone.
Bye.